The Part Played by Accident in Invention and Discovery by Ernst Mach. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. It is characteristic of the naive and sanguine beginnings of thought in youthful men and nations that all problems are held to be soluble and fundamentally intelligible on the first appearance of success. The sage of Miletus, on seeing plants take their rise from moisture, believed he had comprehended the whole of nature, and he of Samos, on discovering that definite numbers corresponded to the lengths of harmonic strings, imagined he could exhaust the nature of the world by means of numbers. Philosophy and science in such periods are blended. Wider experience, however, speedily discloses the error of such a course, gives rise to criticism, and leads to the division and ramification of the sciences. At the same time, the necessity of a broad and general view of the world remains, and to meet this need, philosophy parts company with special inquiry. It is true, the two are often found united in gigantic personalities, but as a rule their ways diverge more and more widely from each other. And if the estrangement of philosophy from science can reach a point where data unworthy of the nursery are not deemed too scanty as foundations of the world, on the other hand, the thorough-paced specialist may go to the extreme of rejecting point-blank the possibility of a broader view, or at least of deeming it superfluous, forgetful of Voltaire's apothegm, nowhere more applicable than here, le superflu, chose très nécessaire. It is true, the history of philosophy, owing to the insufficiency of its constructive data, is and must be largely a history of error. But it would be the height of ingratitude on our part to forget that the seeds of thoughts which still fructify the soil of special research, such as the theory of irrationals, the conceptions of conservation, the doctrine of evolution, the idea of specific energies, and so forth, may be traced back in distant ages to philosophical sources. Furthermore, to have deferred or abandoned the attempt at a broad philosophical view of the world from a full knowledge of the insufficiency of our materials is quite a different thing from never having undertaken it at all. The revenge of its neglect, moreover, is constantly visited upon the specialist by his committal of the very errors which philosophy long ago exposed. As a fact, in physics and physiology, particularly during the first half of this century, are to be met intellectual productions which for naive simplicity are not a jot inferior to those of the Ionian school, or to the Platonic ideas, or to that much reviled ontological proof. Latterly there has been evidence of a gradual change in the situation. Recent philosophy has set itself more modest and more attainable ends. It is no longer inimical to special inquiry. In fact, it is zealously taking part in that inquiry. On the other hand, the special sciences, mathematics and physics, no less than philology, have become eminently philosophical. The material presented is no longer accepted uncritically. The glance of the inquirer is bent upon neighboring fields, whence that material has been derived. The different special departments are striving for closer union, and gradually the conviction is gaining ground that philosophy can consist only of mutual, complemental criticism, interpenetration, and union of the special sciences into a consolidated whole. As the blood in nourishing the body separates into countless capillaries, only to be collected again and to meet in the heart, so in the science of the future all the rills of knowledge will gather more and more into a common and undivided stream. It is this view, not an unfamiliar one to the present generation, that I propose to advocate. Entertain no hope, or rather fear, that I shall construct systems for you. I shall remain a natural inquirer. Nor expect that it is my intention to skirt all the fields of natural inquiry. I can attempt to be your guide only in that branch which is familiar to me, and even there I can assist in the furtherment of only a small portion of the allotted task. If I shall succeed in rendering plain to you the relations of physics, psychology, and the theory of knowledge, so that you may draw from each profit and light, redounding to the advantage of each, I shall regard my work as not having been in vain. Therefore, to illustrate by an example how, consonantly with my powers and views, I conceive such inquiries should be conducted, I shall treat today, in the form of a brief sketch, of the following special and limited subject, of the part which accidental circumstances play in the development of inventions and discoveries. When we Germans say of a man that he is not the inventor of gunpowder, we impliedly cast a grave suspicion on his abilities. But the expression is not a felicitous one, as there is probably no invention in which deliberate thought had a smaller and pure luck a larger share than in this. It is well to ask, are we justified in placing a low estimate on the achievement of an inventor because accident has assisted him in his work? Huygens, whose discoveries and inventions are justly sufficient to entitle him to an opinion in such matters, lays great emphasis on this factor. He asserts that a man capable of inventing the telescope without the concurrence of accident must have been gifted with superhuman genius. A man living in the midst of civilization finds himself surrounded by a host of marvelous inventions, considering none other than the means of satisfying the needs of daily life. Picture such a man transported to the epoch preceding the invention of these ingenious appliances, and imagine him undertaking in a serious manner to comprehend their origin. At first, the intellectual power of the men capable of producing such marvels will strike him as incredible, or, if we adopt the ancient view, as divine. But his astonishment is considerably allayed by the disenchanting yet elucidative revelations of the history of primitive culture, which to a large extent prove that these inventions took their rise very slowly and by imperceptible degrees. A small hole in the ground with fire kindled in it constituted the primitive stove. The flesh of the quarry, wrapped with water in its skin, was boiled by contact with heated stones. Cooking by stones was also done in wooden vessels. Hollow gourds were protected from the fire by coats of clay. Thus from the burned clay accidentally originated the enveloping pot, which rendered the gourd superfluous, although for a long time thereafter the clay was still spread over the gourd, or pressed into woven wickerwork before the potter's art assumed its final independence. Even then the wickerwork ornament was retained as a sort of attest of its origin. We see thus it is by accidental circumstances, or by such as lie without our purpose, foresight and power, that man is gradually led to the acquaintance of improved means of satisfying his wants. Let the reader picture to himself the genius of a man who could have foreseen without the help of accident that clay handled in the ordinary manner would produce a useful cooking utensil. The majority of the inventions made in the early stages of civilization, including language, writing, money, and the rest, could not have been the product of deliberate methodical reflection, for the simple reason that no idea of their value and significance could have been had except from practical use. The invention of the bridge may have been suggested by the trunk of a tree which had fallen athwart a mountain torrent, that of the tool by the use of a stone accidentally taken into the hand to crack nuts. The use of fire probably started in and was disseminated from regions where volcanic eruptions, hot springs, and burning jets of natural gas afforded opportunity for quietly observing and turning to practical account the properties of fire. Only after that had been done could the significance of the fire drill be appreciated, an instrument which was probably discovered from boring a hole through a piece of wood. The suggestion of a distinguished inquirer that the invention of the fire drill originated on the occasion of a religious ceremony is both fantastic and incredible. And as to the use of fire, we should no more attempt to derive that from the invention of the fire drill than we should from the invention of sulphur matches. Unquestionably, the opposite course was the real one. I must not be understood as saying that the fire drill has played no part in the worship of fire or of the sun. Similar phenomena, though still largely veiled in obscurity, marked the initial transition of nations from a hunting to a nomadic life and to agriculture. Compare on this point the extremely interesting remarks of Dr. Paul Carus in his Philosophy of the Tool, Chicago, 1893. We shall not multiply examples, but content ourselves with the remark that the same phenomena recur in historical times, in the ages of great technical inventions, and further, that regarding them the most whimsical notions have been circulated, notions which ascribe to accident an unduly exaggerated part, and one which in a psychological respect is absolutely impossible. The observation of steam escaping from a tea kettle and of the clattering of the lid is supposed to have led to the invention of the steam engine. Just think of the gap between this spectacle and the conception of the performance of great mechanical work by steam for a man totally ignorant of the steam engine. Let us suppose, however, that an engineer, versed in the practical construction of pumps, should accidentally dip into water an inverted bottle which had been filled with steam for drying and still retained its steam. He would see the water rush violently into the bottle, and the idea would very naturally suggest itself of founding on this experience a convenient and useful atmospheric steam pump, which by imperceptible degrees, both psychologically possible and immediate, would then undergo a natural and gradual transformation into Watt's steam engine. But granting that the most important inventions are brought to man's notice accidentally and in ways which are beyond his foresight, yet it does not follow that accident alone is sufficient to produce an invention. The part which man plays is by no means a passive one. Even the first potter in the primeval forest must have felt some stirrings of genius within him. In all such cases, the inventor is obliged to take note of the new fact. He must discover and grasp its advantageous feature, and must have the power to turn that feature to account in the realization of his purpose. He must isolate the new feature, impress it upon his memory, unite and interweave it with the rest of his thought. In short, he must possess the capacity to profit by experience. The capacity to profit by experience might well be set up as a test of intelligence. This power varies considerably in men of the same race, and increases enormously as we advance from the lower animals to man. The former are limited in this regard almost entirely to the reflex actions which they have inherited with their organism. They are almost totally incapable of individual experience, and considering their simple wants are scarcely in need of it. The ivory snail, Eburna spirata, never learns to avoid the carnivorous actinia, no matter how often it may wince under the latter shower of needles, apparently having no memory for pain whatever. A spider can be lured forth repeatedly from its hole by touching its web with a tuning fork. The moth plunges again and again into the flame which has burnt it. The hummingbird hawk moth dashes repeatedly against the painted roses of the wallpaper, like the unhappy and desperate thinker who never wearies of attacking the same insoluble chimerical problem. I am indebted for this observation to Professor Hatschek. As aimlessly almost as Maxwell's gaseous molecules, and in the same unreasoning manner, common flies in their search for light and air stream against the glass pane of a half-opened window and remain there from sheer inability to find their way around the narrow frame. But a pike, separated from the minnows of his aquarium by a glass partition, learns after the lapse of a few months, though only after having butted himself half to death, that he cannot attack these fishes with impunity. What is more, he leaves them in peace even after the removal of the partition, though he will bolt a strange fish at once. Considerable memory must be attributed to birds of passage, a memory which, probably owing to the absence of disturbing thoughts, acts with the precision of that of some idiots. Finally, the susceptibility to training evinced by the higher vertebrates is indisputable proof of the ability of these animals to profit by experience. A powerfully developed mechanical memory, which recalls vividly and faithfully old situations, is sufficient for avoiding definite particular dangers, or for taking advantage of definite particular opportunities. But more is required for the development of inventions. More extensive chains of images are necessary here, the excitation by mutual contact of widely different trains of ideas, a more powerful, more manifold, and richer connection of the contents of memory, a more powerful and impressionable psychical life, heightened by use. A man stands on the bank of a mountain torrent, which is a serious obstacle to him. He remembers that he has crossed just such a torrent before on the trunk of a fallen tree. Hard by, trees are growing. He has often moved the trunks of fallen trees. He has also felled trees before and then moved them. To fell trees he has used sharp stones. He goes in search of such a stone, and as the old situations that crowd into his memory and are held there in living reality by the definite, powerful interest which he has in crossing just this torrent, as these impressions are made to pass before his mind in the inverse order in which they were here evoked, he invents the bridge. There can be no doubt but the higher vertebrates adapt their actions in some moderate degree to circumstances. The fact that they give no appreciable evidence of advance by the accumulation of inventions is satisfactorily explained by a difference of degree or intensity of intelligence as compared with man. The assumption of a difference of kind is not necessary. A person who saves a little every day, be it ever so little, has an incalculable advantage over him who daily squanders that amount, or is unable to keep what he has accumulated. A slight quantitative difference in such things explains enormous differences of advancement. The rules which hold good in prehistoric times also hold good in historical times, and the remarks made on invention may be applied almost without modification to discovery, for the two are distinguished solely by the use to which the new knowledge is put. In both cases, the investigator is concerned with some newly observed relation of new or old properties, abstract or concrete. It is observed, for example, that a substance which gives a chemical reaction A is also the cause of a chemical reaction B. If this observation fulfills no purpose but that of furthering the scientist's insight, or of removing a source of intellectual discomfort, we have a discovery. But an invention, if in using the substance giving the reaction A to produce the desired reaction B, we have a practical end in view and seek to remove a source of material discomfort. The phrase disclosure of the connection of reactions is broad enough to cover discoveries and inventions in all departments. It embraces the Pythagorean proposition, which is a combination of a geometrical and an arithmetical reaction, Newton's discovery of the connection of Kepler's motions with the law of the inverse squares, as perfectly as it does the detection of some minute but appropriate alteration in the construction of a tool, or of some appropriate change in the methods of a dyeing establishment. The disclosure of new provinces of facts before unknown can only be brought about by accidental circumstances, under which are remarked facts that commonly go unnoticed. The achievement of the discoverer here consists in his sharpened attention, which detects the uncommon features of an occurrence and their determining conditions from their most evanescent marks, and discovers means of submitting them to exact and full observation. Under this head belong the first disclosures of electrical and magnetic phenomena, Grimaldi's observation of interference, Arago's discovery of the increased check suffered by a magnetic needle vibrating in a copper envelope as compared with that observed in a bandbox, Foucault's observation of the stability of the plane of vibration of a rod accidentally struck while rotating in a turning lathe, Mayer's observation of the increased redness of venous blood in the tropics, Kirchhoff's observation of the augmentation of the D line in the solar spectrum by the interposition of a sodium lamp, Schonbein's discovery of ozone from the phosphoric smell emitted on the disruption of air by electric sparks, and a host of others. All these facts, of which unquestionably many were seen numbers of times before they were noticed, are examples of the inauguration of momentous discoveries by accidental circumstances, and place the importance of strained attention in a brilliant light. But not only is a significant part played in the beginning of an inquiry by cooperative circumstances beyond the foresight of the investigator, their influence is also active in its prosecution. Dufay thus, whilst following up the behavior of one electrical state which he had assumed, discovers the existence of two. Fresnel learns by accident that the interference bands received on ground glass are seen to better advantage in the open air. The diffraction phenomena of two slits proved to be considerably different from what Fraunhofer had anticipated, and in following up this circumstance he was led to the important discovery of grating spectra. Faraday's induction phenomenon departed widely from the initial conception which occasioned his experiments, and it is precisely this deviation that constitutes his real discovery. Every man has pondered on some subject. Every one of us can multiply the examples cited by less illustrious ones from his own experience. I shall cite but one. On rounding a railway curve once, I accidentally remarked a striking apparent inclination of the houses and trees. I inferred that the direction of the total resultant physical acceleration of the body reacts physiologically as the vertical. Afterwards, in attempting to inquire more carefully into this phenomenon, and this only, in a large whirling machine, the collateral phenomena conducted me to the sensation of angular acceleration, vertigo, Florin's experiments on the section of the semicircular canals, etc., from which gradually resulted views relating to sensations of direction, which are also held by Breuer and Brown, which were at first contested on all hands, but are now regarded on many sides as correct, and which have been recently enriched by the interesting inquiries of Breuer concerning the macula acustica, and Kreidel's experiments with magnetically orientable crustacea. Not disregard of accident, but a direct and purposeful employment of it advances research. The more powerful the psychical connection of the memory pictures is, and it varies with the individual and the mood, the more apt is the same accidental observation to be productive of results. Galileo knows that the air has weight. He also knows of the resistance to a vacuum, expressed both in weight and in height of a column of water. But the two ideas dwell asunder in his mind. It remained for Torricelli to vary the specific gravity of the liquid measuring the pressure, and not till then was the air included in the list of pressure-exerting fluids. The reversal of the lines of the spectrum was seen repeatedly before Kirchhoff, and had been mechanically explained, but it was left for his penetrating vision to discern the evidence of the connection of this phenomenon with the questions of heat, and to him alone, through persistent labor, was revealed the sweeping significance of the fact for the mobile equilibrium of heat. Supposing that such a rich organic connection of the elements of memory exists, and is the prime distinguishing mark of the inquirer, next in importance certainly is that intense interest in a definite object, in a definite idea, which fashions advantageous combinations of thought from elements before disconnected, and obtrudes that idea into every observation made, and into every thought formed, making it enter into relationship with all things. Thus Bradley, deeply engrossed with the subject of aberration, is led to its solution by an exceedingly unobtrusive experience in crossing the Thames. It is permissible, therefore, to ask whether accident leads the discoverer, or the discoverer accident, to a successful outcome in scientific quests. No man should dream of solving a great problem unless he is so thoroughly saturated with his subject that everything else sinks into comparative insignificance. During a hurried meeting with Mayer in Heidelberg once, Jolly remarked, with a rather dubious implication, that if Mayer's theory were correct, water could be warmed by shaking. Mayer went away without a word of reply. Several weeks later, and now unrecognized by Jolly, he rushed into the latter's presence, exclaiming, "Es ist so! It is so! It is so!" It was only after considerable explanation that Jolly found out what Mayer wanted to say. The incident needs no comment. This story was related to me by Jolly, and subsequently repeated in a letter from him. A person deadened to sensory impressions, and given up solely to the pursuit of his own thoughts, may also light on an idea that will divert his mental activity into totally new channels. In such cases it is a psychical accident, an intellectual experience, as distinguished from a physical accident, to which the person owes his discovery, a discovery which is here made deductively by means of mental copies of the world, instead of experimentally. Purely experimental inquiry, moreover, does not exist, for as Gauss says, virtually we always experiment with our thoughts. And it is precisely that constant corrective interchange or intimate union of experiment and deduction, as it was cultivated by Galileo in his dialogues, and by Newton in his optics, that is the foundation of the benign fruitfulness of modern scientific inquiry, as contrasted with that of antiquity, where observation and reflection ofttimes pursued their respective courses like two strangers. We have to wait for the appearance of a favorable physical accident. The movement of our thoughts obeys the law of association. In the case of meagre experience, the result of this law is simply the mechanical reproduction of definite sensory experiences. On the other hand, if the psychical life is subjected to the incessant influences of a powerful and rich experience, then every representative element in the mind is connected with so many others that the actual and natural course of the thoughts is easily influenced and determined by insignificant circumstances, which accidentally are decisive. Hereupon the process termed imagination produces its protean and infinitely diversified forms. Now, what can we do to guide this process, seeing that the combinatory law of the images is without our reach? Rather let us ask, What influence can a powerful and constantly recurring idea exert on the movement of our thoughts? According to what has preceded, the answer is involved in the question itself. The idea dominates the thought of the inquirer, not the latter, the former. Let us see now if we can acquire a profounder insight into the process of discovery. The condition of the discoverer is, as James has aptly remarked, not unlike the situation of a person who is trying to remember something that he has forgotten. Both are sensible of a gap, and have only a remote presentiment of what is missing. Suppose I meet in a company a well-known and affable gentleman whose name I have forgotten, and who to my horror asks to be introduced to someone. I set to work according to Lichtenberg's rule, and run down the alphabet in search of the initial letter of his name. A vague sympathy holds me at the letter G. Tentatively I add the second letter, and am arrested at E. And long before I have tried the third letter R, the name Gerson sounds sonorously upon my ear, and my anguish is gone. While taking a walk, I meet a gentleman from whom I receive a communication. On returning home, and in attending to weightier affairs, the matter slips my mind. Moodily, but in vain, I ransack my memory. Finally, I observe that I am going over my walk again in thought. On the street corner in question, the selfsame gentleman stands before me and repeats his communication. In this process are successively recalled to consciousness all the precepts which were connected with the precept that was lost, and with them finally that too is brought to light. In the first case, where the experience had already been made and is permanently impressed on our thought, a systematic procedure is both possible and easy, for we know that a name must be composed of a limited number of sounds. But at the same time it should be observed that the labor involved in such a combinatorial task would be enormous if the name were long and the responsiveness of the mind weaker. It is often said, and not wholly without justification, that the scientist has solved a riddle. Every problem in geometry may be clothed in the garb of a riddle. Thus, what thing is it that M which has the properties A, B, and C? What circle is that which touches the straight lines AB but touches B in the point C? The first two conditions marshal before the imagination the group of circles whose centers lie in the line of symmetry of AB. The third condition reminds us of all the circles having centers in the straight line that stands at right angles to B in C. The common term or common terms of the two groups of images solves the riddle, satisfies the problem. Puzzles dealing with things or words induce similar processes, but the memory in such cases is exerted in many directions, and more varied and less clearly ordered provinces of ideas are surveyed. The difference between the situation of a geometer who has a construction to make and that of an engineer or a scientist confronted with a problem is simply this, that the first moves in a field with which he is thoroughly acquainted, whereas the two latter are obliged to familiarize themselves with this field subsequently, and in a measure far transcending what is commonly required. In this process the mechanical engineer has at least always a definite goal before him, and definite means to accomplish his aim, whilst in the case of the scientist that aim is in many instances presented only in vague and general outlines. Often the very formulation of the riddle devolves on him. Frequently it is not until the aim has been reached that the broader outlook requisite for systematic procedure is obtained. By far the larger portion of his success, therefore, is contingent on luck and instinct. It is immaterial, so far as its character is concerned, whether the process in question is brought rapidly to a conclusion in the brain of one man, or whether it is spun out for centuries in the minds of a long succession of thinkers. The same relation that a word solving a riddle bears to that riddle is borne by the modern conception of light to the facts discovered by Grimaldi, Roemer, Huygens, Newton, Young, Malus, and Fresnel, and only by the help of this slowly developed conception is our mental vision enabled to embrace the broad domain of facts in question. A welcome complement to the discoveries which the history of civilization and comparative psychology have furnished is to be found in the confessions of great scientists and artists. Scientist and artist, we might say, for Liebig boldly declared there was no essential difference between the two. Are we to regard Leonardo da Vinci as a scientist or as an artist? If the artist builds up his work from a few motives, the scientist discovers the motives which permeate reality. If scientists like Lagrange or Fourier are in a certain measure artists in the presentation of their results, on the other hand, artists like Shakespeare or Ruysdael are scientists in the insight which must have preceded their creations. Newton, when questioned about his methods of work, could give no other answer but that he was wont to ponder again and again on a subject. And similar utterances are accredited to D'Alembert and Helmholtz. Scientists and artists both recommend persistent labor. After the repeated survey of a field has afforded opportunity for the interposition of advantageous accidents, has rendered all the traits that suit with the mood or the dominant thought more vivid, and has gradually relegated to the background all things that are inappropriate, making their future appearance impossible, then from the teeming, swelling host of fancies which a free and high-flown imagination calls forth, suddenly that particular form arises to the light which harmonizes perfectly with the ruling idea, mood, or design. Then it is that that which has resulted slowly as the result of a gradual selection appears as if it were the outcome of a deliberate act of creation. Thus are to be explained the statements of Newton, Mozart, Richard Wagner, and others, when they say that thoughts, melodies, and harmonies had poured in upon them, and that they had simply retained the right ones. Undoubtedly, the man of genius, too, consciously or instinctively, pursues systematic methods wherever it is possible, but in his delicate presentiment he will omit many a task or abandon it after a hasty trial, on which a less endowed man would squander his energies in vain. Thus the genius accomplishes, in a brief space of time, undertakings for which the life of an ordinary man would far from suffice. I do not know whether Swift's Academy of Schemers in Lagado, in which great discoveries and inventions were made by a sort of verbal game of dice, was intended as a satire on Francis Bacon's method of making discoveries by means of huge synoptic tables constructed by scribes. It certainly would not have been ill-placed. We shall hardly go astray if we regard genius as only a slight deviation from the average mental endowment, as possessing simply a greater sensitiveness of cerebral reaction and a greater swiftness of reaction. The men who, obeying their inner impulses, make sacrifices for an idea instead of advancing their material welfare, may appear to the full-blooded Philistine as fools. Yet we shall scarcely adopt Lombroso's view, that genius is to be regarded as a disease, although it is unfortunately true that the sensitive brains and fragile constitutions succumb most readily to sickness. The remark of C.G.J. Jacobi that mathematics is slow of growth and only reaches the truth by long and devious paths, that the way to its discovery must be prepared for long beforehand, and that then the truth will make its long-deferred appearance as if impelled by some divine necessity, all this holds true of every science. We are astounded often to note that it required the combined labors of many eminent thinkers for a full century to reach a truth which it takes us only a few hours to master, and which once acquired seems extremely easy to reach under the right sort of circumstances. To our humiliation, we learn that even the greatest men are born more for life than for science. The extent to which even they are indebted to accident, to that singular conflux of the physical and the psychical life in which the continuous but yet imperfect and never-ending adaptation of the latter to the former finds its distinct expression, that has been the subject of our remarks today. Jacobi's poetical thought of a divine necessity acting in science will lose none of its loftiness for us if we discover in this necessity the same power that destroys the unfit and fosters the fit. For loftier, nobler, and more romantic than poetry is the truth and the reality. End of The Part Played by Accident in Invention and Discovery by Ernst Mach.